So today we're going to start talking about negative numbers. We're not going to do any operations with them today, like adding and subtracting, but we're going to put them on a number line. We're going to talk about which ones are larger than other ones, and then also what categories do they fall into. And that's where we're going to start. So there's three categories we're going to talk about today, and we'll really kind of briefly mention another. The natural numbers, the whole numbers, the integers, and we'll also touch on rational numbers. But before we do that, we're going to take a look at this chart right here, and we're going to kind of fill in some teachers in different spots that fit the correct circles. All right, and then we're going to match that up to our math. So this is called a Venn diagram. So we have overlapping circles. So anything that overlaps means that it's shared. So in here, I put math teachers, but I can't just put any math teachers because it is inside the 7th grade teachers circle. So if they're inside the math teachers circle, they're also inside the 7th grade teachers circle. So for instance, I could not put Ms. Butters in here. She would have to go in a different spot because she is not a 7th grade teacher. So she's a math teacher, but she shouldn't go inside the 7th grade teachers circle. So teachers out here, I could put myself. I could put Miss Butters. I could put Mr. Hinken. I could put Miss Esther. Okay. Now inside 7th grade teachers, I could also put myself and Hester, Hinken. If you wanted to add O'Boyle, you could. But what I can't do is put Butters in here because Butters is not a 7th grade teacher. Now inside the math teacher's circle, which is also inside the 7th grade teacher's circle, the only one that you can put is me. Or if you want to include Miss Bechtel, then she could go in there as well. Okay, but I can't put O'Boyle in there. He's not a math teacher. And I can't put Butters in there because she's not a 7th grade teacher. So any name that I see inside this big box represents a teacher. Doesn't matter where they are in any of these circles, they're a teacher if they're in this box. If they're in this circle, they're a 7th grade teacher. And then if they're in this circle, they're a 7th grade teacher who teaches math. And so there's a select few of those. Okay, so we're going to do the same thing over here after we talk about these different types of numbers. So our natural numbers, these are the numbers that you first start learning as a child. And we call these our counting numbers. So the first number you learn as a child is 1, and then you learn 2, and then you learn 3, and then you keep getting larger and larger and larger. Okay, those are our counting numbers. So let's put 1, 2, 3, and these go on forever. These are whole numbers, so you learn 20, you learn 100. Okay, natural numbers would also include really, really large numbers. If you had 999, that's a natural number. They're positive. You know nothing about negatives yet as a child. Okay, and they're whole numbers. We're not talking decimals or fractions. Those are your natural numbers. Whole numbers include naturals. So that's why this circle is inside the whole numbers. 1 is natural. 1 is also a whole number, just like Kerr is a math teacher, but Kerr is also a 7th grade teacher. It's just a bigger category. So the bigger category here is whole numbers. All of these are included. So I can put these numbers out here, 1 and 2 and 3 and 20 and 100, 999. They go in both spots. But we add one more number to the whole numbers. And this is a number you learn kind of when you start going to school. You don't learn it as a child necessarily, but the number is 0. And so we can put 0 out here. So all of these numbers go in both circles because they're included in both categories, but 0 only goes in the whole numbers. Okay, it's not a natural number. So 0 is a whole number. All the rest of them are shared. All right, and now integers. This includes all our whole numbers. So everything we put in here, we could put out here. 0, 1, 2, 3, 100, 99. So 0 while it's a whole number, it's also an integer because it's in the big box. It's included in everything. Just like everything in here, Kerr was a teacher. Even though Kerr is a math teacher, he still falls under the bigger teacher spectrum. So integers is the bigger category. All of this fits into integers, but it's not just whole numbers. It's also their opposites. And the opposite of a positive whole number is a negative whole number. So 3 and negative 3, 99 and negative 99. 1 and negative 1, 2 and negative 2, 100 and negative 100. Now you might notice that I skipped 0. 0 doesn't have an opposite. 0 is not positive or negative. It's right in the middle of those two sets. So it doesn't have an opposite, but it falls under integers. Okay. So let's slide down here. And it says, please place the following numbers on the number line and then label them. So we're just going to talk about where do these go on the number line and then how do we label them. So we should be able to find number 7. If we're going to count each one of these as just one spot, it's 1, 2, 3, 4, 5, 6, 7. Now notice where I put the point. It's right on the cross section right here. It's not floating up top. It's not anywhere else. Right on the corner there. And I need to label it, so I'm going to put a number 7. You can put it on the top or the bottom. It doesn't matter. So there's 7. Now negative 7 is the opposite. So I start at 0 and I go the opposite direction. 1, 2, 3, 4, 5, 6, 7. Put that point right on the graph, not floating below, not floating up here. Label it, that's negative 7. Okay, same distance from 0, just in the opposite direction. Now 2.7. So 2.7 is a little more than 2. Here's 1, here's 2, so it's going to be a little more. If I went directly between 2 and 3, that's 2.5. That's 2.5. 2.7 is bigger than 2.5, so it's actually closer to 3. So I need to make sure I show that. So here is 2.7. Negative 2.7 is the same distance from 0, just in the opposite direction. So I went up 2 and then almost to 3. So I'm going to go down 2 and almost to negative 3. So negative 2.7 is almost to negative 3. It's closer to negative 3 than it is to negative 2. 3.8. 1, 2, 3. Here's 4. 3.5 is in the middle, so 3.8 is up a little bit closer to 4. So negative 3.8 is going to be closer to negative 4. 1, 2, 3. Here's 3.5. Here's 4. It's going to be almost to 4. Negative 3.8. A half. We know a half is right between 0 and 1. That's like 0.5. I'm going to label this one on top just to show you that you can. And negative a half is going to be in the opposite direction, so between 0 and negative 1. So here's negative 1/2. Last one. 4 and 3/4, just talking fractions now. Here's 1, here's 2, 3, 4. 4.5 would be here, so 4 and 3/4 is a little more. And negative 4 and 3/4. 1, 2, 3, 4. Negative 4.5. Negative 4 and 3/4 a little bit further. All right. What value does each point have? So we're going to count from 0. We're going to assume that each tick is worth 1. You can make these worth whatever you want, so you need to be careful. There should be a key, and you can see. If there's no key, it's usually safe to assume, though, that the ticks are 1. So if I'm starting with letter A, counting from 0, it's 1, 2, 3, 4 away from 0. It's to the left, so that means it's less than 0, which makes it negative. So it's negative 4. B is 1 away from 0. To the left, it's less than, so that's negative 1. C goes the opposite way, but the same distance. So it's 1 away, but it's in the positives, so positive 1. And letter D, 1, 2, 3 away in the positive direction. So the digit, the 1, the 4, the 1, the 3, tells you how far it is from 0. And then the negative and the positive tells you which direction, left or right. You could also do up and down. All right, so you try these. Either pause the video or I'll give you a second. See if you can label these. So if this is 0, going all the way to letter H, 1, 2, 3, 4, 5, 6, 7. Okay, it's in the negative direction, so it's -7. Well, going up 1, I'm going to be 1 less in terms of my distance from 0. So that's 6, and it's -6. Go up another 2, that's -4. 1, 2, 3, 4. L sits at -1. M is 0. Counting up to 3, 4, 5, 6, 7, and 8. Okay, what are 3 different ways to express the number -6 and +9? Okay, we could write this as just -6. We can write the number like that, -6. We could call this the opposite of 6. Now I know it says 3 different ways, but if we wanted to add a 4th, we could say 6 less than 0. So we really start comparing these numbers to 0. How far are they from 0? So +9, you could write out in words. You could write it as +9. You could write it as just 9. We don't have to put the positive sign. We could say it's the opposite of -9. And this is 9 more than 0. Now I've started using some of these terms, or at least the language that is involved with these terms. So the vocab here at the bottom. An inequality, if you look above the whiteboard, or I'm sorry, the wall of fame, you can see some examples of inequalities. So if we break this word down, equality means equal. So inequality means not equal. So these are going to be symbols that represent or representing relationships that are not equal. And feel free to pause the video if you need to catch up on any of this. So inequalities, symbols representing relationships that are not equal. So for example, our greater than sign, and we'll talk a little bit more about that. Our less than sign, greater than or equal to, less than or equal to. Okay, and we're going to use these to compare some of these numbers. This number is greater than this number is less than this. Opposite numbers we already touched on. Okay, an example of opposite numbers is 6 and -6, 9 and -9. But if we had to write a definition of opposite numbers, we would say it's the two numbers that are the same distance from 0. It's the two numbers the same distance from 0. The only two numbers that are 6 away from 0 are 6 and -6. The only two numbers that are 10 away from 0 are 10 and -10. So it's the two numbers that are the same distance from 0. Now absolute value is that actual measurement, how far a number is from 0. So absolute value is the distance a number is from 0. Now absolute value is expressed with these bars around a number. So this says the absolute value of 10. How far is 10 from 0? Well, 10. What about the absolute value of -10? How far is -10 from 0? It's 10. So an absolute value is always positive because we're measuring distance. So even when we have a negative number, it's 10 away from 0. So absolute value just measures the distance a number is from 0. How far is it from 0? So opposite numbers are the same distance. That's why +10 and -10 have the same absolute value. They're the same distance from 0. All right, flip it over. Real quick. We're going to order these numbers from least to greatest. So first of all, negative numbers are always smaller than positives. So we need to start with our negatives. And if you think about a number line with 0 in the middle, the first number next to it is -1 if I'm going in the negative direction. And if I go all the way over here, if you think about these numbers here, -40 is going to be way over here. -8 is going to be in here somewhere. Okay, and -1/2 goes here. So the farther left a number is, the smaller it is, because if you think about, if we put 10 over here, we know 50 is up here. And if I'm comparing these two numbers, 10 is less. And 0 is less than both of these because it's farther to the left. So the farther left I go in the negatives, the smaller it gets. So -40 is my smallest number in this group. Now we have a -8, we have a -8.9. Think about the distance from 0. -8 is here, so -8.9 is even further to the left. So -8.9 is smaller. -8 would be next. We got to take care of all our negatives before we can touch a positive, because every negative number is smaller than any positive number. So -1/2 comes next. If there was a 0, 0 would split your positives and your negatives. Now we should be able to order positive numbers. We have a fraction. That's going to be the smallest, 3/4. We have a 4 and a 4.5, so 4 comes first. 4.5 comes next. 10 and 50. All right, so let's use these inequalities to compare some numbers. 7's greater than 4, but what does that look like as an inequality? So you may have learned this in elementary school, that this is like the alligator mouth, and it's always open towards the larger number. It's trying to eat the larger number. So since 7 is bigger than 4, it's open, and you read this from left to right. 7 is greater than 4. So comparing -1 and 1, okay, positives are always bigger, so the alligator needs to be open towards the 1. But you read this from left to right still. -1 is less than 1. So here, -6 and -7. Think about your number line. Here's 0. Which number do I get to first is -6. Then I get to -7. The farther left it is, the smaller it is. So 7 is actually smaller, which makes -6 bigger. So the alligator is going to try and eat the -6. If I read this from left to right, it says -6 is greater than -7. So right here, -10 and 0. Well, negatives are smaller than positives. Negatives are also smaller than 0. So the bigger number here is 0. And now I have two negatives. Sometimes those are a little tricky to compare. And if we're on a number line, fractions sometimes don't fit in our minds on a number line as easily as whole numbers. So let's think about these as positives for a second. If these were positive numbers, which one's bigger? Well, 3/4 is bigger than 1/4, right? Well, negatives are opposite. So that means -1/4 is bigger than 3/4. And if, again, we started at 0, let's say this is number 1 over here. As I go towards the positive 1, I'm going to have 1/4, and then closer to it, I'm going to have 3/4. So going this direction, I'm going to have -1/4, and I'm going to have -3/4. All right. I want you to try the rest of this page. See how you do. And I will come around and check this before you go.